Now we're at the last part. We talk about the distance time graph. So from the name we know that the time is the independent variable, which means that it is in the x-axis, and the distance is the dependent variable, which is the y-axis. So as you can see from the graph, distance being in the y-axis and the time being in the x-axis, okay, because it is an independent variable. So take a look at these two parts here. This is how you determine what type of graph it is. So for distance time graph, the y-axis is distance, x-axis is time. Now, so how does it look like? Generally, distance at the y-axis, time at the x-axis. So some of the basics that you must note, okay, that for the distance time graph, the slope indicates the speed of the object, okay, it indicates the speed. So for steep slope, okay, straight line, steep straight line slope, it means it's a, take note of this word here, is a constant high speed, because it is steep, that's why it is high speed. Okay, let me erase this to tick. Okay, steep, that's why it is high speed. Now, if it is a gentle slope, it means it's a low speed. Okay, low speed. Gentle slope, low speed. Just take note of this. Once again, it is constant. Okay, now the other basic about your distance time graph is to take note of the flat line. Flat line, it means that the object is not moving. We will go into further details. Example. Okay, example seems like it's not there, so let me use this as an example. So you can see here, this slope here tells you how fast or how slow the thing is moving. This line here, since a flat line, tells you that my object is not moving. So this part, okay, my object is not moving. Okay, for this part here, you know that my object is traveling at constant speed. Okay, traveling at constant, okay, because it is a straight line slope. So now, let's take a look. How is the distance time graph related to a speed time graph? Okay, you can see that when there's a constant speed, okay, the distance increases steadily. So constant speed, you can see the distance slowly increase. So we look at time from 0 to 10 seconds. When the speed is constant, the distance gradually increase. Now, how do we know what's the distance traveled? So what you'll do is, okay, let me move this here a bit. Okay, now I know it has been traveling, the object has traveled 1 meters per second for 10 seconds. So what's the distance traveled? You will realize that at the end of the 10 seconds, the distance traveled is how much? Equals to 10 meters. Because my speed is 1, but my time is 10 seconds. So it has traveled 10 meters. So after 10 seconds, I know that my object must have traveled 10 meters. So I know from 0, it has increased all the way to 10. So this is how we can plot when the speed is constant. Okay, so when the speed is constant, the distance increases steadily. So you'll see a very nice straight line over here. Now, when there is no speed, okay, which means that the speed is 0, the distance traveled remain constant. Just think of it. If I'm not moving, is my speed going to increase or decrease? Is my distance going to increase or decrease? Definitely not. It's just going to remain same. So when the speed is 0, the object is not moving, the distance remains at 10 meters traveled. Okay, so you can see for speed time to distance time is just quite easy. When there's a straight flat line, okay, the distance increase steadily. And how do we know what's the distance covered? We take the speed multiplied by the time taken, in this case 10 seconds. Okay, so then when the speed is 0, the distance remains the same at 10 meters. Okay, in this case here. Okay, so this is regards to the basic of a distance time graph. Now let's try practicing. How do we draw the distance time graph for the following speed time? We know that at this part here, we can split it into two regions. Region A, okay, is this part over here. Okay, and region B. Region B, we put it over here. Okay, all the way until 20 seconds. So region A, region B. You can see in region A the speed is constant at 2 meters per second. So that means I'll expect my graph to have this kind of a shape. It should increase at the start. Now, after that, when it reaches 10 seconds, you can realize that the speed is 0. So my distance must remain constant. So I expect such a graph. Okay? So this is distance, this is time. Now, the only question left is, what's the distance traveled? What's this point over here? How do we find out what's the distance over here? What you'll do is, take 2 multiplied by 10, because distance is equals to speed times time. So this equals to 2 multiplied by 10, so it's 20 meters. So I'll know that this value over here is 20 meters. So my distance time graph will look as such. You can see it will increase to 20 and remain at 20 for the next 10 seconds. So this is the speed time graph given to us. This is the distance time graph which you should have plotted. Okay, so just take note of it. Next one, we try again. How will the distance time graph for the following speed time graph look like? So same thing, let's try to draw it out. Okay, distance time. Okay, time is in seconds, distance is in meters. So initially, the speed is 0. So from 0 to 5, you expect that the distance is constantly at 0. Now, after 5, you realize there's a steady speed at 5 meters per second, constant speed. So I know that there will be a straight line up all the way. Okay, because it's a constant speed. Now, the question lies in, so what's the distance covered? So what's the distance covered? Okay, so distance covered is equals to speed times time. So we know that the speed from here is 5 meters per second. But what's the time here? You realize that we are measuring the time from 5 seconds onwards until 10 seconds. So the time frame is actually how many seconds? 10 minus 5, which is only 5 seconds. So the distance traveled is actually 25 meters. So this point over here, the distance traveled will be 25 meters. So just take note of this. So you can see from the next slide, it is 0 and then it travels all the way to 25. Now the last one. How will the distance time graph for the following speed time graph look like? Okay, so let's draw our standard distance time graph first. Okay, distance, time. Okay, seconds, meters. Okay, now from 0 to 5, we know that there's a steady speed at 5 meters per second. So we know that it will be gradually increasing. Now the next one, the speed increased from 5 to 10, but it's still constant. So how are we going to make the two lines look different? Very simple. Remember at the start we talked about the basics. Okay, the basics over here. Steep slope represents constant high speed. Gentle represents constant low speed. So you can see this is a constant speed, constant speed. This is lower, so it should be gentler. 10 meters per second is a higher speed. So now we should draw a steeper slope. Can see here? Okay, this line here is gentler. This line over here is steeper. Okay, this is how we can draw to distinguish both of them. Now, what's the distance covered? So for the first region over here, okay, we can take distance equals to speed times time. So the speed is 5, the time is 5, so it's 25 meters. So we know that for this region over here, it is 25 meters. How about the second part? Okay, sorry, let me erase the meter there, because the units is already there. Okay, how about this part over here? We know that it traveled 10 meters per second for the next 5 seconds. So this part here, the distance traveled, okay, is equals to 10 multiplied by 5 seconds. You can see it traveled 10 meters per second for only 5 seconds. So this is 50 meters. Now, common mistake that people tend to do is, since this is 50, the marking here must be 52. But the truth is it traveled 25 already, then it traveled another 50. So what is the total distance traveled? It now has become 75. So at this point here is a 75 meters. So let's look at the graph. So you can see for the first 5 seconds it traveled 25 meters. After that, the the object carried on travel another 50 meters to reach 75. So take note, when there is two constant speed, you got to add up the distance. Okay, you have to, when there are two constant speed, if two constant speed is present, are present, okay, you have to add up both distance. Okay, so you have to add up the distance to find the final distance. So we know that initially it traveled 25 meters here, it traveled another 50. So 25 here, how to reach 75 is because of the 50 over here. Okay, 50. So just take note of this. So we have completed your the speed time graph to a distance time graph. So this is the end for your forces affecting speed.